An ecological, A-Life, interactive music generation tool. This project demonstrates an interactive music generation tool using a set of user-generated A-Life or artificial life form simulations. For example, Langton's ants, Cellular Automata, and Flocking Boids that sense their environment, in this case a tone matrix, change the environment over the course of their lives, and play music that results from this. There are different algorithms that we use to create the system and the A-Life simulations. Firstly, the environment is a tone matrix with either chords or notes representing each cell. The cells can in turn be off or on. There are numerous A-Life agents in this particular system. The first one, Langton's ants. These agents, on sensing the square they are on, do one of two things. If they are on a square that is on, they turn right 90 degrees, toggle its value off and on, and then take a step forward in their direction of orientation. If instead they are on a square that is off, they turn left 90 degrees, toggle its value off or on, and take a step forward in their direction of orientation. Secondly, cellular automata, in this case Conway's game of life. These represent bacteria or microorganisms and operate by sensing the squares around them. If there are less than 2 neighbors for a live cell, the cell dies due to underpopulation, setting the square to off. If there are 2 or 3 neighbors for a live cell, the cell lives on. If there are greater than 3 neighbors for a live cell, it dies due to overpopulation, setting the square to off. If there are 3 neighbors for a dead cell, it is reborn, setting the square to on. Finally, flocking boids. These boids represent flocks of birds and move, well, each one represents a bird, and the group together represents a flock of birds, and they moved according to 3 rules that control the flocks of birds. Firstly, boids steer to avoid crowding other boids in the neighborhood, also known as separation. Boids steer towards the average heading of other boids in their neighborhood. This is known as alignment. And finally, boids steer to move towards the center of mass or average position of other boids in their neighborhood, aka cohesion. Additionally, the music is played by using the center of mass of the flocks of boids. The center of mass plays the note or chord it is on at a quantized interval after smoothing its movements using exponential moving average or EMA. EMA has the formula such that at time t equals 0, S0, or the smooth value at time 0, is equal to the current instantaneous value x0. At any other time, t equals small letter t, S of t, or the smooth value at time t, equals alpha into x of t, or the current value at t, plus 1 minus alpha into s of t minus 1, or the smooth value up till one time period before this. Alpha is the smoothing coefficient and was chosen to be 0.25 in this particular example. The key conjecture here in this particular project is that the use of an ecosystem of simple dynamical systems like A-Life simulations can generate emergent complexity to create interesting music, especially while interacting with each other. It is also conjectured that the different agents contribute to the entire experience, creating better results than if any one species were to be used alone. This is still an interactive tool and not an autonomous music generation system, since it requires and encourages the human to interact with it in order to instantiate the A-Life species and influence them through notes or chord manipulations. The human also tunes the parameters of the various simulations to make it sound aesthetically more pleasing. For example, the flocking boids with lower number of boids, faster maximum velocity, and faster maximum acceleration parameters seem better in terms of music generation, since they form more cohesive flocks that merge together when nearby, making the center of mass for their movements more variable and interesting as a tool with which to play the tone matrix. The various artificial life forms do interact with each other, directly and indirectly through the environment in order to generate interesting and complex behavior. This can be seen when ants provide newfound stimuli to stable or dead automata populations, or when the automata create patterns that control the ants' movements. Additionally, the use of the center of mass as a single point of reading the tone matrix provides a control over the chaos that dynamical systems can cause during their generation. The non-linearity of the flocking movement also seems to create a feeling that the system is being played by something that isn't purely mechanical. In the future, I would love to continue this by adding more kinds of simulations that could potentially add to the generation process. I think the single center of mass could be improved as well by adding multiple playheads or play spots that dynamically appear according to the number of distinct flock clusters that emerge over time. In conclusion, this system works. The tool itself is usable and has been used in numerous examples by numerous people to create pieces of music that are generated infinitely. The ecosystem works together to create better music than any one system or simulation of alive characters alone. For instance, the cells and the ants create more on notes or chords in a single time slice than a time slice based approach to playing the tone matrix sounds nice with. The flocking approach adds some variation and constrains the number of notes played closely together or at once. This makes it sound more like a living being playing the system or playing music than a uniform machine. The ants help the cells since the cells can die out due to the nature of their dynamical system or can be stable without change in a stable state. So the ants perform a service to the cells. The cells, on the other hand, influence the movement of the ants, getting them to explore more of the space. The human works as a caretaker for this ecosystem, influencing all the other species. Thus each species depends on the other to create music together.